in semiconductor electronics. So in the first video, we discussed some of the topics of very chapter. Now we'll move further and let's see the further topics. P-type semiconductor, N-type semiconductor. P-type semiconductor, it is formed by doping with a trivalent impurity. N-type semiconductor, it is formed by doping with a pentavalent impurity. In P-type semiconductor, number of holes is greater than number of electrons. In N-type semiconductor, number of electrons is greater than number of holes. p-n junction. It is an arrangement made by a close contact of N-type semiconductor and P-type semiconductor. Two important processes occur during the formation of p-n junction: diffusion and drift. During the formation of p-n junction and due to difference in the concentration of charge carriers, holes diffuse from p side to n side and electrons diffuse from n side to p side. This motion of charge carries gives rise to diffusion current across the junction. Drift is the process of movement of charge carriers due to the net electric field. During the formation of p-n junction and due to difference in the concentration of charge carriers, holes diffuse from p side to n side and electrons diffuse from n side to p side. This motion of charge carriers gives rise to diffusion current across the junction. Drift is the process of movement of charge carriers due to the net electric field. Thus, when a hole diffuses from p side to n side, it leaves behind an acceptor negative charge which is immobile. As the holes continue to diffuse, a layer of negatively charged immobile ions is developed on the p side. On the p side of the junction, the diffused charge carriers combine with their counterparts in the immediate vicinity of the junction and neutralize each other. The region on either side of the junction which becomes depleted from the mobile charge carriers is called the depletion region or depletion layers, whose width is of the order of 10 to the power minus 6 meter. This sets up a potential difference across the junction and an internal electric field E directed from N side to P side. This electric field setup stops further diffusion of majority charge carriers. Forward and reverse biasing of p-n junction diode. When an external voltage V is applied across the diode such that P side is connected to the positive terminal of the battery and N side to the negative terminal, it is said to be forward biased. When an external voltage V is applied across the diode such that P side is connected to the positive terminal of the battery and N side is negative terminal, it is said to be forward biased. Similarly, when N side is positive and P side is negative, it is said to be reverse biased. Forward bias. When the diode is forward biased, an external electric field is set up from P side to N side to oppose the internal electric field. The holes move along the field E and electrons move opposite to its, eliminating the depletion layer. A current is thus set up in the junction diode. As the applied voltage is low, the current through the diode is almost zero. Because of the potential barrier or knee voltage, the current increases sharply once the applied voltage exceeds the barrier voltage. Reverse bias. Due to reverse biasing, an external field E is established to support the internal field EI. Under this biasing, the holes in P region and the electrons in N region are pushed away from the junction to when the depletion layer and hence increases the size of the potential barrier. Therefore, the junction does not conduct. When the reverse bias is made sufficiently high, the covalent bonds near the junction break down, releasing large number of free electrons and holes, and the current increases abruptly to high value. This is called avalanche breakdown and may damage the junction. Application of a diode as a rectifier. The conversion of AC into DC is called rectification, and the device arrangement is called a rectifier. So what rectifier does? It converts AC into DC. There are two types of rectifiers: half wave rectifier and full wave rectifier. During positive half cycle of the input AC, the PN junction is forward biased. Thus, the resistance in PN junction becomes low and current flows. Hence, hence we get output in the load. During negative half cycle of the input AC, the PN junction is reverse biased. Thus, the resistance of the junction is high and the current does not flow. Hence, no output in the load. So, for complete cycle of AC, current flows through the load resistance in the same direction. The output voltage is unidirectional but pulsating. This process is called half wave rectification and the arrangement is called half wave rectifier. Full wave rectifier. During the first half of input cycle, the upper end of the coil is at positive potential and lower end at negative potential. The function diode D1 is forward bias and D2 is reverse bias. Current flows in output load resistance in the direction shown in the figure. During the second half of input cycle, D2 is forward biased. In this way, current flows in the load in the single direction. Now we will discuss some of the multiple choice question. In semiconductors at room temperature, so the correct answer is the valence band is partially empty and the conduction band is partially filled. So A is the correct answer. So A is the correct answer. If no external voltage is applied across PN junction, then there would be. If no external voltage is applied across PN junction, then there would be an electric field pointing from N-type to P-type side across junction. Choose the only false statement from the following. Substances with energy gap of the order of 10 electrovolt are insulator. The conductivity of a semiconductor increases with increasing temperature. In conductors, the valence and conduction bands may overlap. The resistivity The resistivity of semiconductor increases with increase in temperature. And the answer is, which is the false, is third one. Second one. The conductivity of a semiconductor increases with increase in temperature. So this is a false statement. A semiconducting device is connected in series circuit with a battery and a resistance. A current is found to pass through the circuit. If the polarity of the battery is reversed, the current drops to almost zero. The device may be a PN junction. A PN photodiode is fabricated from a semiconductor with a band gap of 2.5 electrovolt. It can detect a signal of wavelength. And the correct answer is 4000 angstrom. The dominant mechanism for the motion of charge carriers in forward and reverse bias silicon PN junction are. And the correct answer is diffuse in forward bias, drift in reverse bias. Diffuse in forward bias and drift in reverse bias. The impurity atoms with which pure silicon should be doped to make a p-type semiconductor are those of, and the answer is boron. In the middle of the depletion layer of reverse bias PN junction, the electric field is nearly zero. In a full wave rectifier, in a full wave rectifier circuit operating from 50 Hz main frequency, the fundamental frequency in the ripple would be, answer is C, 100 Hz. If the ratio of the concentration of electrons to that of holes in a semiconductor is 7 by 5 and the ratio of current is 7 by 4, then what is the ratio of their drift velocities? And the answer is 5:4. So I hope you like today's video. So if you like, so do not forget to like and please share this video with your friends. Thank you. Have a nice day.